Hello again. We have been discussing stress and stress management for the past couple of weeks. We started our discussion on the prevalence of stress. Then we went on to discussing some of the common causes of stress as believed by people. And then we discussed some of the common effects that stress has on people's health. In the last video, I focused my attention on defining stress. Now, all this discussion has important implications on stress management. And I hope you realize this because once we understand how prevalent stress is, we will realize the gravity of the problem. We right now may not be feeling stressed, but once we understand how prevalent stress is, we know that we are in danger of being stressed as well. Once we realize how stress impacts people's health, then we realize that, hey, stress can be extremely harmful to us. And then when we are stressed, we would take steps to manage it better. Or we may even take preventive measures so that we don't get extremely stressed. And in the last video, when I discussed what exactly stress is and trying to see stress from its from a perspective that helps us be in control so that we don't feel helpless, so that we then can manage stress better. So we defined stress as what we experience when we perceive the demands to be higher than our capacity, right? So then we focus on building our capacities. And if we have higher capacity to deal with whatever demands that come our way, then we will be able to deal with those demands without actually feeling stressed. So from a long-term perspective, we should all be focusing on building our capacity. Now that diagram that I shared with you, it has other implications too. We will discuss those things later. But in today's video, I am going to focus more on some of the immediate implications of you being stressed. And most of this knowledge comes from some of the initial research that has happened in the area of stress. Now, this initial research is not centuries old, but rather about 1 century old. So unlike some of the other disciplines, the research in the area of stress is relatively new. So most of the research has happened in the 20th century and now, of course, into the 21st century. I just for a moment lost track of my years. So in today's video, we will discuss some of the origins of stress research. I will primarily focus on two big names, Hans Sully and Walter Cannon. Those are the two big names we will be discussing today and their research. But just because this is a little dated research, or I shouldn't use the word dated, it's a little old research. These research happened in the 1930s, 1940s, 1950s. Does not mean that it is not relevant today. It is actually highly relevant. And you will understand the relevance of it when you get to know about the research. Because as you can see in the diagram, or rather in the figure that you see here, you see these guinea pigs here. So most of this initial research was very biological kind of research. And of course, our human conditions may have changed from the 1930s, 1940s. We now live in an internet era, we now have no job security, which probably was present half a century ago. So some of our life conditions may have changed, but the biology, our human biology, hasn't changed, right? The human biology, or for that matter, biology of animals, take millions of years, thousands of years, millions of years to change through the process of evolution. So, what research was done in the 1930s, 40s, 50s still applies today. With that background, let's now delve into that research. So, well, we discussed how stress is the cause of 80% of our ailments. Visits to physicians can be attributed to stress, and about 50% of the deaths can be attributed directly to stress in form of different heart issues, heart diseases, diabetes, even cancer, for that matter, even infections, because when you are highly stressed, your immunity levels go down. So, on one hand, one could say that somebody died because of being infected with certain flu, but it is also related to stress in the sense that the person's immunity was down because of the person being stressed for a prolonged period of time. So you can see that stress is harmful. But then the question is, why is it that animals don't suffer from some of these human ailments in form of heart disease, in form of ulcers? Why is it the case? Of course, animals do suffer from these problems, but when they are in the wild, they do not suffer from these problems. So animals in captivity do suffer from heart disease, ulcers, and even psychological problems. But why is it that animals in the wild do not have ulcers, do not have heart disease? Well, one explanation could be that they probably eat healthy, natural food, and that's a valid explanation, right? They are active, and our current lifestyle is very sedentary. Which can then decrease our capacity to deal with the challenges that we have. Remember, I define stress as the mismatch between our demands and capacity, right? When the demand exceeds our capacity, we will be stressed. Now, again, one of the possible reasons we are more stressed is because of our reduced capacity. If we have been sitting most of our lives, then our capacity reduces to deal with physical challenges, at least, right? It will actually reduce our psychological capacity too, but that's a different point which you may not be able to appreciate right now. We will come to that. But still it doesn't explain why animals in wild do not have some of these ailments that are so common amongst human beings. Because in the wild, there's a risk for animals to be eaten, or for the predator to not get food. So irrespective of whether you are a predator or prey, there is a reason for animals to be stressed as well. The predator will go hungry if it doesn't get a prey, and the prey will get killed, will be eaten up by a predator. So there is a risk of life, risk to their lives, literally. In contrast, our lives are not in danger for the most part, unless we are in some war-torn area where then our life will be at risk. Otherwise, our lives are not at risk. We are in pretty safe, comfortable environment. Imagine if we lived in some war-torn area like Syria, then we would be highly stressed because our lives will be in danger. So the same analogy then should apply to animals, right? Animals, imagine we are talking about this deer or the baby deer, which would be a fawn, right? The deer's life will be in danger. So on a day-to-day basis, any day the predator could jump on the deer and eat it. So there should be a lot of reasons for the animals to have this prolonged stress and consequently develop these heart problems, ulcers, and diabetes. And why don't they have these problems? It's because once the animal is out of danger, the animal is not then stressed anymore. The animal is back to its calm self and maybe grazing the field. Only when there is the real threat, real danger, do animals get stressed. And they will, either fight or try to flee the danger as much as possible. And either they get eaten, if not, then if they survive, then they are relieved, and they're then not worrying about, oh, what if the tiger is hiding somewhere else? Now, I had seen a tiger there yesterday. Maybe the tiger will kill me today. They are not worrying about some danger. They are back to living their lives essentially, right? Now, human beings, in contrast, we have this thinking capacity which animals do not have. Now, that's a double-edged sword. That thinking capacity has helped us make tremendous advances in science and technology that has made our lives very comfortable. But that thinking capacity also makes us worry about things which may not be clear and present danger in our lives. We may worry about the future. We may be feeling guilty about something in the past from 10 years ago, from 20 years ago. So these are not clear and present danger, but that worry, that anxiety about what if I do not get a job in the next 2 years, or when I graduate, what if I do not get a job? And then that causes me to worry, and that causes me to feel stressed. But that's not a clear and present danger like your life being threatened, right? So this thinking capacity can itself be a problem for us if we do not have any control over our thoughts. So anyway, how does this relate? Let's go back to the research that has been done on this particular topic. By the way, the points that I'm discussing, there's a really nice book that is titled Why Zebras Don't Get Ulcers. It's, I think, about 10 years old, but it's a good book. So some of you, if you are still looking for a book for your summary and reflection assignment, you probably could use this book. And there are many other great books too, but this relates to the discussion that we are having right now. Essentially, the exact same question that I asked: why don't animals in wild not get these diseases? So this leads to our first researcher, Walter Cannon. Now, he was a physiologist, a physician. Okay, so he was a professor at Harvard Medical School. He coined two important terms that are relevant to stress research. He is one of the pioneers in stress research. One term, or one of the phrases that he coined was the fight or flight response. Now, this is, of course, excuse me, known to everyone now. It's common parlance now, right? But he's the person who coined this term, and we will discuss its relevance to stress. And the second term that he coined was homeostasis. If you remember your biology classes from maybe high school, or you probably remember the term homeostasis, but if not, we will discuss it today. And both these terms are relevant to stress, experience of stress, and how we manage stress. So we will first start with homeostasis. So right now, the temperature outside is very cold. There's snow covered everywhere. But inside, I'm just wearing a shirt, right? I'm not fully covered up. How is that the case? Because there is the thermostat and there is the heater in my room, and the room's temperature, my apartment's temperature, is managed by the thermostat. That if the temperature goes too below, it makes the heater run and the temperature comes to the temperature at which it is set. In summer, it would be the opposite, right? The air conditioner will start running, or the fan will start running when it is too hot in the apartment. Now, our body is also very intelligent. So we essentially have a thermostat in a way in our body, because we will not be able to survive if our body gets extremely heated, as happens when you get high fever, or if your body gets extremely cold when you get hypothermia. Our body can survive only within a certain temperature range. So for adults, it's like anything between 97.9 to 99 degrees Fahrenheit, right? So there's a range. Within that range, our body functions very effectively. When the temperature goes below that range or above that range, and if it is going too far away from that normal range, then it increases the risk of we dying, because our organs will start failing, and we will potentially get killed. We will die. So our body, again, the mechanisms we will discuss later in the biology of stress. And so there's a lot of biological discussion that we will be doing. So get geared for that. But at a very superficial level, when we are cold, our body starts shivering, right? And through that process, our body gets heated and we feel a little warmer. When we are out in the hot, we start sweating, and then the sweat gets evaporated and we then feel a little cooler. So that's how our body's temperature is being maintained. So this process through which that ideal temperature or that normal range of temperature is achieved, or that balanced state, is called rather homeostasis. So when we are shivering, our body temperature increases. When we are sweating, our body temperature goes down, and that stability, that dynamic state of balance, that dynamic state of equilibrium that is attained, which is very important for our body to function optimally, that is what we call is homeostasis. Homeo means same. So stasis is a state. So homeostasis, the sameness of the state, where even though outside conditions are varying dramatically, our internal state is remaining the same. That's the basic idea. So that's what homeostasis is. So if we are extremely hot or cold, in both the cases, homeostasis will bring the temperature back to normal. But homeostasis is not just about our physical temperature. Temperature regulation is just one part of it. There are a lot of other aspects too. So temperature regulation is one thing, but how much of water in the body, our blood glucose levels, our sodium levels, and it's a whole host of factors uh, are constantly getting balanced through a complex series of mechanisms, which again you don't have to worry getting seeing this complex mind map, even though we will be touching upon some of these things later. But if our pH levels, everything needs to be in proper balance for our body to function optimally. And this balanced state, this equilibrium state, that is obtained by the body, that is called homeostasis. Okay. Now, actually, let's do a quick quiz. Well, quiz in the sense. So, would this be a good metaphor for homeostasis? So this guy, he can balance all kinds of stuff. Let's see. Here you see him balancing a washing machine. You get the idea. So he has this unique ability to get the exact spot where everything is balanced, even though it seems tilted, but the center of gravity and everything is balanced from all the three dimensions. And unless it's of course a very delicate balance, if you push it, it will fall. But he succeeds in achieving this balance for really complex objects. So he's a showman. So this balanced state that we see here, is this a good example of homeostasis? My question to you guys. If you said yes, because in homeostasis also we get the balance, right? It's a balanced state. But actually the answer is wrong. Why? Because in homeostasis, it's a dynamic equilibrium. There's constant forces applying in either directions. And there's a lot of processes that are happening in the background to keep that balance. It's not a static thing. Now, in this case though, initially, of course, he has to work to find out that right spot where there will be perfect balance for this washing machine. But once he has found that spot, if he leaves it, it will stay in balance. It's not going to fall unless there is some external force that gets applied, even if in form of somebody just touching it. But without any external force getting applied on it, it's not going to fall, right? So this is actually not a good metaphor for homeostasis. In contrast, this will be a great metaphor for homeostasis. So you see these athletes, acrobats, balancing the body. Now, this is a great example of homeostasis. Why am I saying that? Because these acrobats, they are constantly working to get that perfect balance. So their muscles are working really hard to get that perfect balance. So it's a dynamic balance. When we are talking about homeostasis, we need to realize that it's a dynamic process. It's an active process. It's not a passive, static process. So it's not a static thing. Rather, it's an active process. You are actively working to achieve that balance. So even stress response is a dynamic process. And again, you will understand what I'm saying as we move through the slides. So homeostasis and stress, these are both dynamic processes. So our body is constantly working hard to achieve that state of balance. That state of balance that is achieved is called homeostasis. True, but it's a dynamic state of balance. Its body is constantly working to achieve that state. So we need to understand two other concepts. One is allostasis. Allostasis is the process, is the background process that goes on to achieve that balance. Okay, so that dynamic balance state is called homeostasis, but all the background processes that is happening in the body to achieve that balanced state, that is what we call allostasis. Okay, so all the physiological and behavioral, so your body is shivering, and through that, if you are achieving that balance, that process of shivering, that would be allostasis. Following me? And there will be a lot of other internal mechanisms that are happening too. Our body, like if you are in the cold, if you fall in the some ice water, your blood will start rushing away from the extremities and go to your major core to keep that part of the body warm, because that's more important for your survival. The extremities you can afford to lose extremities and still survive, but if your body gets too cold, your core gets too cold, you will die, right? So all those internal processes that are happening, that are happening to achieve that balance of homeostasis, that is called allostasis. Okay, now the second important term that you need to understand is called allostatic load. So all those processes that are happening in the body to get that balance, it takes a toll on the body. There's a wear and tear of the body that happens when your body is working hard to achieve that homeostatic state. One point I just mentioned, like your blood moving away from your extremities. Now, isn't that a wear and tear on your body? The body is preserving the core, but your extremities are potentially getting damaged. If you are exposed to cold for too long a period, you may actually have to be amputated, right? So that's an extreme example, but there is a cost to homeostasis. Homeostasis helps in our survival, true, but there is a cost to that, and that cost that the body pays through its wear and tear, that is called the allostatic load. So what implications does this have on stress? So if it is a some acute stress because of my life being in danger, because I saw a snake or some wild animal that could potentially kill me, there is immediate stress there. But if I successfully survive that danger, and if I'm out of the danger, then my body will come back to homeostasis. But that's not always the case. Many a times we have these dangers for a long periods of time. They are not life-threatening dangers, but if I'm worrying about something, stress can be imagined. So then my body is going off balance, and then my body has to work really hard for prolonged periods of time to achieve that homeostatic state. And that has a toll on my body because of that allostatic load. Okay. So this is what I was saying, if I'm having money problems for really long periods of time, if I'm having work-related problems for really long periods of time, if the person whom I'm married to is is an abuser, let's say, so if I'm exposed to prolonged stress for long periods of time, then my body will still be working to maintain homeostasis, but it takes a toll on the body. That is called the allostatic load, and that's what then leads to all kinds of physical ailments, problems. But in case of acute stress, when there is an imminent threat to life, we engage in what is called the fight or flight response. And as I mentioned, that was coined by Walter Cannon in 1939. So what happens in this fight or flight? Our body, again, through this homeostatic process, you realize, because stress is in a way, there's a lot of physical things that are going on. Actually, I will share that in the next slide. So we will go through the nervous system in detail later on, but broadly speaking, we have two systems in place. One is the sympathetic nervous system, which is the fight or flight part of the nervous system. Okay, what they do anytime that we are in danger, it will the body goes into this hyper vigilant mode. Our pupils will dilate, our salivation will go down, but our heart rate will go up. Our airway, so that we can breathe shallow and fast, so that we get some more air to fight or flight. Our survival is not as important. Our digestion is not as important at that point of time, because more important is to be able to deal with the threat, that imminent threat. So our stomach activity will go down, and whole series of things, whole series of hormones will get fed into our body. So we will discuss some of these specific things at a later stage. But you realize it is a load on the body, right? If our digestion, because of we feeling stressed for a long period of time, if our digestion is getting inhibited, then we will then have lot of gastrointestinal problems. We will start developing ulcers. But from a survival perspective, this was important. It was important that the body reduced its supply of resources to digestion when there is an imminent threat, so that all the resources could be transferred to our muscles, to our visual acuity and our hearing acuity, so that we can then either detect the danger and fight the danger, or flee from the danger, right? So once the person is out of danger, what happens is that our parasympathetic nervous system comes into play, which is the rest and digest system. So our body calms down, which is what was happening with those deers. Once they are out of danger, the body is calming down. So danger leads to the fight or flight response. Then we have the parallel rest and digest system. Both of these are working in parallel. So our body is always going little either in the fight or flight direction or in the rest and digest situation. And as the situations demand, as the environmental challenges come in our way, we either go slightly in the fight or flight direction or in the rest and digest system. So that's what's happening. So in the fight or flight response, we have the sympathetic nervous system, which helps us survive, but then over a longer period of time, it takes toll on our body. You can imagine if there is not enough secretion going to your stomach, then of course you will have problems. Or if there is too much of blood supply going to your heart, if your heart is pumping too much of blood, then it will get tired, right? It will start developing irregular heartbeats, which will then lead to all kinds of difficulties. So that's the fight or flight response, as discussed by Walter Cannon. Now, there is a third response that can happen too, which is the freeze response. So fight or flight was what was Walter Cannon initially proposed, but what we have also seen is the freeze response, where you are so scared in front of danger that you literally freeze. So when does that happen? My understanding of the freeze response is typically that it happens when the demand, the danger, the challenge is way too high and your capacity to deal with it is way too low. Okay, so you are in essentially in this zone. So when you have some abilities to, I think I need to take a step back. So both to fight as well as to flight, you need resources. You need, even to run away, you need to have the ability to run faster than the predator to survive, right? So you need those physical abilities to both for fight as well as flight. Fight, of course, you can understand. You do need those physical resources, but you also need those resources for flighting, for fleeing away from the danger. What if your capacity is really low? Then that's when we tend to see the freeze response. So it's like when you freeze, there is a less likelihood that the predator will be able to notice you, because predators tend to have better visual acuity for movement than for something that is very static, right? So maybe through that process, by luck, the predator won't notice you and you will survive. Maybe the predator will think that you're already dead and the predator will not get the satisfaction of killing you, playing dead, right? All kinds of evolutionary factors come into play that also contribute to the freeze response. So fight, flight, or freeze. So it's not just fight or flight anymore, but fight, flight, or freeze. But all of these responses have some biological mechanisms behind. The next researcher we will be talking about is Sully. He's called the father of stress research. So he was also he came little after Walter Cannon, but he's the person who essentially made stress research mainstream. So he was influenced by Walter Cannon's research who preceded him, and Sully defines stress as the wear and tear of the body. And remember, Walter Cannon had mentioned that as well in form of allostatic load, right? So Sully also emphasizes that. Sully says that stress is a non-specific response of the body to any demand for change. Okay, so stress is your body's response to demands that come from the outside. Now, what does this mean? Actually, it's really fascinating how Sully stumbled on the area of stress, because he was actually not interested in doing research on stress. He was, I think, working at McGill University in Montreal. He was a young researcher, had just gotten his PhD. He was an endocrinologist, researchers who work on the different hormones. At that point of time, one of his colleagues had actually isolated a particular hormone, and he wanted to see what effect does that hormone have on bodies, on human body. But of course, before you start doing research on human bodies, you start on guinea pigs. So he started injecting that chemical that had been isolated on these guinea pigs. And unfortunately, Sully was a very clumsy man. So while he would try to lift the guinea pigs and inject them, often these guinea pigs would escape and then he would have to run behind them to get hold of them and catch them, and find the syringe and give the injection. So there was a lot of this melee that happened when Sully was injecting these substances into the bodies of these guinea pigs. But his assistant, he was not clumsy. So Sully was doing this for a set of guinea pigs. Now his assistant was working on a set of another guinea pigs, but he was a very refined person, so he didn't have any of these problems that Sully was having when he was trying to inject the guinea pigs. Now, after a period of time, over months, it turned out that many of these guinea pigs that Sully was handling, they developed all kinds of physical ailments, okay, but not the guinea pigs that his assistant was handling. Now, this made it very interesting. So obviously it cannot be the effect of the chemical that was being injected, because it's the same chemical that was being injected to both the groups of guinea pigs. So what was being different? And so Sully may have been a clumsy person, but he was a great scientist. So he thought about it, and this literally becomes an experimental group versus control group, right? So incidentally, he developed that, right? He developed a group that was being treated differently from the control group. And what was that differential treatment? That differential treatment was the way he was handling these guinea pigs, which literally caused them to feel a lot of stress, which then led to those guinea pigs developing a lot of physical ailments, which wasn't happening with his assistant. So, so experimental group, control group, which probably you know from your research methods classes, but that's the reference to it. If you don't know, you could just take a quick read of it when you are watching this video. So in any case, that's how he stumbled on this research on stress, and he went on to do lots of research on stress. And so Sully coined this term or phrase, general adaptation syndrome. So one of the key differences between Walter Cannon's research and Sully's research is that Sully's research is focusing on slightly longer term effects of stress. Fight or flight response is some immediate response to stress, which is what Walter Cannon focused on. Homeostasis, again, is immediate changes in the body in response to the physical environment, right? That's how the homeostatic state is achieved. Now, allostasis and allostatic load, those are things that came in later. I just discussed that in context of homeostasis. So allostasis and allostatic load, those are concepts that came in much later. In fact, they come from Sully's idea of general adaptation syndrome. But originally, Walter Cannon's research focused on the immediate impact of stress in form of fight or flight response, in form of body trying to achieve homeostasis. Sully's research, again, if you realize, the effect on those guinea pigs was not immediate. They started developing those physical ailments after being exposed to him for a long period of time, right? So that's what is being discussed in the general adaptation syndrome. So when you are exposed to stressors for long periods of time, it can literally make you sick. So the general adaptation syndrome, it has three primary stages. There is the alarm stage, there is the stage of resistance, which is also called the stage of adaptation, and stage of exhaustion. So Sully was again one of the first researchers to note the importance of both the nervous system and the endocrine system in the experience of stress and stress management. So Walter Cannon focused more on the nervous system in form of the sympathetic versus parasympathetic nervous system. But remember, Hans Selye was a endocrinologist. So he was much more in tune with the hormonal system. So many of the stress hormones, which again we will be discussing later, all that knowledge, the root of it comes from Hans Selye's research. Okay. So he noticed that both the nervous system as well as the endocrine system is involved in the general adaptation syndrome. So why is it called a syndrome? Because anytime that you are exposed to a stressor, you get the fight or flight response, which is, so the alarm reaction part. This is the part that Walter Cannon did his research on, the fight or flight response. But what if that stressor you get continued to, if you're excuse me, if your body is exposed to that stressor for long periods of time, then your body will start adapting. Okay. So imagine you grew up in Alaska. Okay, your body is adapted to cold climate, and suddenly, you get a job, let's say in India, or India. Certain parts of India are cold, but so let's say you get a job in some of the hottest part of India. Okay, now it's going to be your body is going to be under stress, but that's where you are working now. So after some period of time, your body will start adapting. Okay, so that is what we are referring to, stage of adaptation or stage of resistance. Going back to going back to examples that are more related to stress. Let's say you are without food, so initially your body feels it as alarm reaction, the predator not getting food. But if you are, let's say, consciously fasting, or you are in some concentration camp where they are not feeding you, then your body gradually starts to adapt. There are a lot of internal changes that are happening to do that, but your body starts adapting, and that is what we are referring to as stage of resistance or stage of adaptation. But that adaptation is at a cost, which is, again, we have already discussed, allostatic load. So when that allostatic load is too much, after a point of time, you get exhausted. You start becoming sick. Your body's immune system gets compromised. So you become more susceptible to even infections, and you will develop heart disease and cancer, diabetes, and all kinds of problems, right? So this is how stress progresses. So this is the short-term immediate stress response. Then if the stress prolongs for a period of time, we see the stage of resistance or stage of adaptation. If you successfully adapt to the new situation, then you will not be feeling stressed anymore. But if that adaptation is not complete, but the body then continues to take a toll, then you will reach the stage of exhaustion. And that's when you start developing diseases. The same general adaptation syndrome now in form of a mind map here. The alarm phase, you see a stress, there's adrenaline, which is the fight or flight response. You either get into panic mode or extremely anxious or whatever. So the adaptation stage is actually healthy. It helps you deal with long, prolonged, chronic kind of stress. But it has a toll, and the effect that it has on the body, that's another term called strain. If you remember from our physics discussion of, or physics definition of stress is the force applied per unit area. But the effect that this stress has on the body, on the physical object, I think I gave the example of this thing pressing on the book. If I press too hard, the book will tear, the paper will tear. So the impact that it has on the object, that is called strain in physics. Same is the case also in context of psychological stress or biological stress. In fact, Hans Selye, in one of his later books, writes that he there is only one regret that he had, that he emphasized the word stress too much and not enough strain. So he says that in his biography, he says that if he had to revisit things, he would emphasize the strain aspect of things more. Though, to be fair, at that point of time, he was a pioneer in his thinking, right? So strain is the effect that it ultimately has on the body. Our body gets strained. Okay. So that's another reason also why he was thinking of not using the term stress, because the term stress has this, at least the way he was studying it, has this implication of it being automatic, both in Walter Cannon's research as well as in Hans Selye's research. Stress is automatic, right? Your body automatically reacts in form of fight or flight. Your body automatically goes into resistance state. But that's something that may not be the case always. You can consciously control response, and that's something that I have been touching upon briefly in my previous lectures. But in any case, there is an automatic aspect too, which is true. There is a biological aspect too, which is automatic. Unless we have consciously developed that capacity to a level that we can withstand any forms of stress, any forms of demands. For most common folks who haven't trained themselves, we will actually respond in this automatic fashion. We will go into the alarm stage, then we will go into the resistance stage, and finally we will get exhausted. So that's the general adaptation syndrome. So to summarize, there are external factors that cause us to feel stressed. Those external factors, we call them stressors. Those factors could be physical, so that could be physical, emotional, relational, social, economics, spiritual. They could be real, they could be imagined, all of those, but they are external to us. So we discussed this: money, work, economy. These are all stressors. We call them technically stressors. Okay. They are external causes of stress, not the internal causes of stress. And the problem is that we cannot completely eliminate stressors, right? So in this cartoon, you see, she says, "I know you used to pull your hair out when you were stressed, but I think it would have been better if you could eliminate the stressor." But sometimes, yes, we can eliminate the stressor. So if we have, for example, a really abusive spouse, then maybe we could divorce the spouse and then live away from that stressor, and that would probably reduce our stress, right? But many times we cannot remove stressors, right? We cannot fire everyone from our lives, so we also need to learn how to deal with these stressors, with these people, or with these challenges in life. So that is what I have been emphasizing a lot. Going back to the stressors could be physical in nature, they could be psychological in nature, what I just mentioned. When you ingest drugs or alcohol, they are also called physical stressors. We technically call them biogenic stressors, anything that you're ingesting or things that have direct impact on your body in form of heat or cold. Then we have the psychosocial stressors. They can be both real or imagined. Like, you worrying about your divorce, or you worrying about getting fired. So that could be a real threat too. So all psychological stresses are not necessarily imagined. Your boss may have told you that, hey, you are getting fired. So starting next month, don't come to work. So it's real then. You are not imagining that you will be fired. You know that you have job only for another 15 days. So Psychosocial stresses need not always be imagined. But in any case, the point is that these are factors outside you. Okay, whether you are taking in some substance or whether you are getting exposed to any extreme natural conditions, environmental conditions, or uh, you are getting exposed to horrible boss or horrible spouse, all those factors, these are outside you. Now, yes, it is true that if you have those stresses, if you have too many of those stresses in life, so you have a horrible spouse, horrible friends, bad boss, you also have money problems, you um, also have people who are sick. If you have too many of those stresses, if you're getting exposed to too many of those stresses frequently, then you will be highly stressed and it will have impact on your health. If you have few but intensity of those stresses is very high, somebody you love, care for is sick, intensity is very high, right? Or duration, you have mild stress, relatively mild stress, or let's say, but it's prolonged for months, for years. All these can have negative impact on your health. But the key thing to remember is that these are factors outside us. These are what we defined as demands, problems coming from the environment. But that's not the only factor that causes us to feel stressed. The internal factor is the capacity. So that's the factor that we also need to take into consideration.